This video guide is used to practice our electron configuration skills, doing not only the electron configuration, but also orbital filling diagrams, the noble gas configurations, identifying the number of valence electrons, and the Lewis dot diagrams. Okay, for the first element, we are going to focus on the electron configuration for the element boron. So as always, we're going to start up here in the corner. We're going to start with 1s2, 2s2, and then 2p1 would be boron. And we'll just write that electron configuration. So here's boron, 1s2, 2s2, 2p1. Okay, so if I want to do the orbital filling diagram for boron, the orbital filling diagram is related very closely to this. Anytime I have an s, I make one line. So there is my 1s. And then the number 2, I notate with these arrows. The one thing that's different is the arrows kind of give you some idea of the spin of the electrons. Notice one's pointing up, one's down, so the spin is opposite. Next, I need a 2s, so I need one line. I'm going to label it 2s, 2. And then anytime I have a p, I need 3 lines. And so I'm going to label this 2p, and since there's only one, it goes on the first line pointing up. And so that is the orbital filling diagram. If I want to do a noble gas configuration, I want to go back to the previous noble gas. So and look at my periodic table, when I back up from boron, the previous noble gas is helium. And so I start from there. So I'm going to start with He, and then I'm going to continue on to 2s2, 2p1. So 2s2, 2p1. For these small elements, that's not much of a shortcut. Now I want to identify the number of valence electrons. And so, as you recall, valence means the outermost energy level. In this case, the outermost energy level is the second. So I have to count both the 2p and the 2s. I don't care that they're traveling some spherically and some planar. I want the total number in the outermost energy level. So I have 2 here and 1 here, so I have a total of 3. And then another way you can kind of tell that boron has 3. Notice here's where boron sits. The Roman numeral that's above it is 3, so that kind of just verifies or double checks the fact that boron has 3 valence electrons. And then when I go to do the Lewis dot diagram, you will recall this is the generic form that I want to use. So I'm going to put the symbol, I'm going to put the first 2 to the right hand side paired together, so those are like representing the s electrons, and then I tend to go like this: 3, 4, 5, 6, 7, 8. The reason in which I do that is because it kind of simulates these 2 as being s, and then like px, py, pz. So these are showing the first 3 going in individually, and then pairing up occurs with 6, 7, and 8. So it's kind of like the s and then the p's. So anyhow, going back, looking at boron, because it has 3 valence electrons, the symbol is B. I'm going to start with the first 2 dots there, and the third one there. That should be boron. Okay, the next element is silicon, so let's take a look at silicon. We're going to start up here again, 1s2, 2s2, 2p, there are 6 of them, 3s2, 3p2, and so we stop there at 3p2. It's in the second location. I do apologize for the symbol. Silicon should be Si, the I should be over here. For whatever reason, when I typed it into PowerPoint, and then I uploaded it here onto my iPad so I could record, it moved some letters around. So if you see some kind of odd letters, just kind of ignore them. But here is silicon. So as I was saying, the electron configuration for silicon, we said was 1s2, 2s2, 2p6, 3s2, and then 3p2. If I'm going to do an orbital filling diagram for silicon, it'll look like this. Start out with a 1s2, 2s2, and then so I need 3 lines for the 2p. I fill them half filled, pointing up, so up, 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 down, down, down. There's 2p6, Here is the 3s2, and then I need 3 lines for 3p and 1, 2. That is the orbital filling diagram for silicon. Now, if I'm going to do the noble gas configuration, looking back to the previous noble gas, I back up. The noble gas, the group 18 element that precedes it is neon. So I'm going to put Ne in square brackets, and then I can start from there. So I go down to sodium, which is the 3s2, 3p2. So that's kind of a nice little shortcut. Once again, looking at the valence electrons. The noble gas configurations are real nice because it gets rid of all of these core electrons. So this is showing you, okay, in the third energy level you have 2 traveling spherically, 2 traveling planar. There should be 4. And looking at silicon here, notice there is a Roman numeral 4 above it. And so we have kind of estimated that correctly. So silicon has 4 valence electrons. And then if I want to do the Lewis dot diagram, I'm going to put the silicon symbol, and I'm going to go 1, 2, 3, 4. Alright, the next element is sulfur. And so once again, we're going to start with the 1s2, 2s2, 2p6, 3s2, 3p, and this is the 4th one, so 3p4. And so let's just write this configuration. So we have 1s2, 2s2, 2p6, 3s2, and then we said 3p, and it was the 4th one over. If I go and do an orbital filling diagram, it'll look like this. 1s2, you need 1 line for the 2s, there's 2s2, I'm going to do 3 lines, I'm going to call it 2p, and they go up, 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 down, 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 3s2, and then 3 lines for the 3p, 1, 2, 3, 4. So we have one that pairs up. Okay, and so now looking at that, we can go back and do the noble gas configuration. And so I find sulfur. I go back. It looks like this one is also neon. It's totally fine. And then I start at the sodium there, so I'm going to start at 3s2 and 3p4. And so for identifying valence electrons, I have 2 here and 4 here, so I have a total of 6. And just to verify, here's sulfur. Look above it, there is a Roman numeral 6. So that's a pretty good indicator that we have 6 valence electrons. And so when I go to draw sulfur, I'm going to put the symbol, and I'm going to go 1, 2, 3, 4, 5, 6 for the Lewis diagram. Okay, this next element is calcium. So we're going to start at the beginning. Once again, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So we stop right there for calcium. Alright, so for calcium, we have 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. So if I draw the orbital filling diagram, I'm going to start with a 1s2. Here's the 2s2. Every time I have a p, I need 3 lines, so 2p, 1, 2, 3, 4, 5, 6, 2p6. Here's my 3s2, and 3p, up, 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 down, 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 so there's my 3p6, and then finally my 4s2. Okay, so now if I want to do the noble gas configuration, I find calcium. There it is. If I go back to the previous noble gas, the group 18 element, it is argon, so I put Ar in square brackets, and then I just start from there, and so it goes argon 4s2, so very short. So once again, basically by putting this argon in square brackets, it means all of this stuff that argon normally has, these core electrons, and then in addition, then it has these 4s2 hanging out here. And so we can identify very easily how many valence it has. There are 2. And just to verify that, here's calcium. Notice there's a Roman numeral 2 above it, and so that kind of tells us that we have 2 valence electrons. And so if I'm going to do the Lewis diagram for calcium, I put Ca with 2 dots to the right side. Okay, the next one is aluminum, so I start with 1s2, 2s2, there's 2p6, 3s2, and 3p1. And there's aluminum, so I'm going to go 1s2, 2s2, 2p6, 3s2, and 3p1. And so orbital filling would look like this: 1s2, 2s2, there's 2p, 3s, there's my 3 lines for my 3p, and I need this first one. If I want to do the noble gas configuration, I go to the prior noble gas, the previous one. It's going to be neon in square brackets, and then it's going to be 3s2, 3p1, and so in looking at this, here's 2, here's 1, all in the third energy level, so it looks like I have a total of 3. And just to verify that, here's aluminum, right above it is the Roman numeral 3, and so once again that kind of tells me I have 3 valence electrons. To do the Lewis diagram, I'm going to put the symbol Al, there's the first 2, and there's the third one. Okay, nitrogen is the next one, so we start with a 1s2, 2s2, 2p, looks like it's the third one over. And so let's just write that, that's 1s2, 2s2, 2p, and the third one. As I go to draw the orbital filling diagram, I look at these, and here it is. It's 1s2, 2s2, and 3 lines for the 2p. It should go 1, 2, 3. And so, in looking at the noble gas configuration of nitrogen, the prior noble gas is helium, so I'm going to put helium in square brackets and continue from there. And so it looks like it goes He, and then 2s2, 2p3. So once again, not saving us a lot of writing, but notice there are the 5 valence. Let's check it. And here's nitrogen, the Roman numeral 5 above it. So it looks like 5 valence electrons. Okay, so 5 valence electrons. And so I'm going to go ahead and put the symbol for nitrogen. I'm going to go 1, 2, 3, 4, 5. So there's the Lewis dot diagram for nitrogen. Okay, the next one is argon. So we're going to start at the beginning again. 1s2, 2s2, 2p6, 3s2, 3p6. There's argon. Okay, let's fix this up, put the R back up here. And so we said, what is it? 1s2, 2s2, 2p6, 3s2, and then 3p6. So if I do the orbital filling diagram, it looks as so. There's my 1s2, 2s2, 3 lines for the 2p. I go 1, 2, 3, 4, 5, 6, 3s2, and then my 3 lines for my 3p, and they are going to be filled as well. And so in looking at this, next I want to do the noble gas configuration. Some people think, oh, this is easy, I just put AR in brackets and I'm done. No, it doesn't work that way. The noble gas, for a configuration of a noble gas, you have to follow the same rules, and so I have to put in square brackets the prior noble gas, which is neon, and I start over at the 3s2, 3p6. And so if I want to look at the total valence electrons, there's 2 traveling spherically, 6 traveling planar, total of 8. And if I want to verify that, here's argon, right above it is the Roman numeral 8, so that's indicative of something having 8 valence electrons. And so when I go to do the Lewis diagram, there's AR, and I go 1, 2, 3, 4, 5, 6, 7, 8. It has its perfect octet, its perfect collection, a noble gas. Okay, the next element is phosphorus. I'm going to start here, 1s2, 2s2, 2p6, 3s2, 3p3. It ends there on the third one. And so I'm going to record that here, 1s2, 2s2, 2p6, 3s2, and 3p3. 3. Okay, if I want to do the orbital filling diagram, it looks like so. 1s2, and there's 2s2, 3 lines for the 2p, 1, 2, 3, 4, 5, 6, 3s2, and then 3 lines for the 3p, and they go like so. Okay, now I want to do the noble gas configuration. I look at the prior noble gas, so back from phosphorus, it looks like it is neon, Ne in square brackets. Then I continue from there, it looks like it's 3s2, 3p3, and so the total number of valence electrons, there are 2 traveling spherical, 3 planar, so a total of 5. And in looking, here's phosphorus, the Roman numeral above it is 5, so looks like we're doing all right. 5 valence electrons. If I want to draw the Lewis diagram, I put the symbol 1, 2, 3, 4, 5. Okay, hang in there, almost done. Here's chlorine, and so we're going to start at the beginning. 1s2, 2s2, 2p6, 3s2, 3p, and it looks like it's the 5th one. And I'm just going to move this L up here. So I have 1s2, 2s2, 2p6, 3s2, and then we said 3p5. If I do the orbital filling diagram, should look like this. 1s2, 2s2, here's 2p, 1, 2, 3, 4, 5, 6, 3s2, and then 3 lines for my 3p, and 1, 2, 3, 4, 5. Alright, if I want to do the noble gas configuration, I go back to the prior noble gas, which was neon, and I go from there. So there's neon. Let's see, it's going to go neon, and then 3s2, 3p5. And so once again, there's 2 traveling spherically, 5 traveling planar, all in the 3rd energy level. There should be a total of 7. And here is chlorine. You look above it, there is a Roman numeral 7. There are 7 valence electrons in chlorine. So if I want to do a Lewis diagram, I put the symbol. There's 1, 2 paired up, 3, 4, 5, 6, 7. There are the 7 for chlorine. Okay, last one. We're going to do zinc. This one's a little more challenging than some of the others because it's a little further down. We're at number 30. So starting from the beginning, we have 1s2, 2s2, 2p6, 3s2, 3p6. This is the 4s2. Then remember when we started with scandium, this was 4s. This is the D block, but the first D is 3D, and so the D lags one behind. If this is 4s, this is 3D. Just as this is going to then be 4D, 5D, 6D, so forth and so on. Coincidentally, just while I'm mentioning it, the F block, which is these down here, notice that lanthanum fills after cesium and barium. And so this one would actually be 6S. Then you go down here to the 4F. And then back up to 5D, 6P. Alright? So anyhow, I digress. Let's go back. So we were up to this part. So we were at 4s2. This was 3D. And if you count across, there are 10. So zinc finishes with 3d10. I'm going to go ahead and move that in. And we said it was 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d10. The orbital filling diagram, I might run out of some room. I might have to lap over, but that's okay. Let's see, we're going to start out with a 1s2, 2s2, draw 3 lines for the 2p and go 1, 2, 3, 4, 5, 6. Here is the 3s2. Here is the 3p, 1, 2, 3, 4, 5, 6. Here is 4s2. And every time I do a D, I need 5 lines. So 1, 2, 3, 4, 5. 3D is going to go in the middle. And since there are 10, I have 5 pointing up and 5 pointing down. So there is 3d10. Alright, and so the next thing I have to do is the noble gas configuration. If I go back to the prior noble gas from zinc, it was argon. And then starting from there, it's going to go 4s2, 3d10. Okay, this is the first one we're going to have to pay a little attention to when we do the valence. These 10 are not valence, because notice they're in the third energy level. The fourth energy level is out further than the third, right? And so these don't count as valence. These are core electrons. The only valence electrons are these, the 4s2. So zinc happens to have 2 valence electrons. And then the one thing I kind of mentioned before was that, these tend to have 1, these have 2 valence, these have 3, these have 4, these have 5, 6, 7, 8, so forth and so on. Notice I skipped this whole middle section. I mentioned previously that these tend to have 2. Sometimes they have 1, sometimes they have weird numbers of valence electrons, but usually they have 2 as a general rule of thumb. And so, if I want to draw a zinc, well, first off I need to say, okay, there's 2 valence electrons. I will place the symbol for zinc and 2 dots. And so that completes that exercise.